Less than 8.4 similar figures in direct scale. Number 1 says a segment below is dilated by a scale factor of 1/4 to form f prime g prime. What is the measure of f prime g prime? So taking this segment and we're going to multiply it by the scale factor of 1/4, which means it gets smaller. Remember, this is over 1 and multiply straight across. You could also simplify if you want to, take out a 2. So 4 divided by 2 is 2, 26 divided by 2 is 13, so that gets 13 halves. I'm sure it'll take that answer, or 13 halves is really 6.5, 6.5. And that's all you do on that one. Number 2 is different because it's talking about an angle. The angle below is the image formed when a figure containing Hij is dilated by a scale factor of 3/4. What is the measure of angle Hij? So no matter how long these rays are, let's say I had them be longer, I could have them be shorter, it doesn't affect the opening of this angle. So really I should have probably made them shorter, because if it's taking the sides and changing my scale factor of 3/4, that would have been 3/4 of the way out. So like to here and here, but it still does not affect the opening, so it'll still be the same. So I don't know if you want to make yourself a note. Angles stay the same with dilations. Number 3, quadrilateral KLMN is dilated by a scale factor of 2/3 to form K prime, L prime, M prime, N prime. What is the measure of side K prime, L prime? So we're looking at this side of 18. We want it to get dilated by a scale factor of 2/3. I would take 18 divided by 3. That's 6. 6 times 2 is 12. And that's all you would do. Number 4, our triangle is dilated by a scale factor of 3 to form this triangle here. So be aware of what it's saying. This has primes after it all. This is the after image. They're wanting the pre-image is what they call it, the image that it started out being. And so something got taken by a scale factor or times 3 to make this. So we would want to take the reciprocal of 3, which would be 1/3 times side for YW. So it's this side. So we take 45 times 1/3, which is really 45 divided by 3, which is 15. And so it makes sense in my head that a 15 times 3 made this 45. Okay, so when you're trying to find the pre-image, multiply by the reciprocal, which is the opposite operation. Number 5, quadrilateral FGHI is similar to quadrilateral JKLM. Find the measure of side JK. Figures are not drawn to scale. Okay, so here's another one I would like to make a proportion of. We're trying to find JK, so I'm going to call it X. I'm going to take 4 and compare it to 22.8 because they're in corresponding positions on this shape. Then I'm going to have 6 is to X. So a proportion is 2 fractions set equal to each other. Then I'm taking 6 times 22.8 and setting it equal to 4 times X. Proportions you always cross multiply. Their cross products will always equal each other, and then that gives us an equation to solve. So 6 times 22.8 is 136.8. And then all I got to do for X is divide by 4. 34.2. And so I know on another thing in notes, I might have done a proportion too fast. So hopefully this makes sense to you. But yeah, I get to where I see numbers that are diagonal, I multiply, and then I divide by the other number. And that's what you're doing in the equation. And number 6, we got a triangle. It's similar to another triangle. Find the measure of side OP. And I would just set up a proportion again. Something else you could do, you could put 2 over 1.4 and set that equal to 6 over X. It doesn't matter as long as you're staying in some kind of order. So I'm going like hypotenuse over leg, hypotenuse over leg. I just couldn't say, okay, 2 is to X, because 2 and X actually have no relationship. So you can work in the same triangle, or you can pick the same sides from the different triangles. Here I'd want to take 6 times 1.4 and divide by 2. And that gets 4.2.